All right, this is chapter 4 review. So we're going to list the order pairs. So we have 5, 0, 5, 5, negative 4, negative, oops, that should be negative 5, negative 5, negative 4, sorry, negative 2, 1, should be 0, 1, 2, 3, 4, 5, 6. We should have 1, 2, 3, negative 1, 2, 3, 4. And a last point, 1, 2, 3, 4, 5, 6, 7, 7, 2. Just to make sure that I have all my points, 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. Very good. Create a map. So I'm going to start with my x values. So I have a negative 5, a negative 2, 0, 3, and 7. Remember, we don't put any duplicates. This is just my domain listed out. So now I'm going to list out my range. I have a 0, a negative 4. Is that a negative 1? No, it's positive 1. 6. I have another negative 4. And then I have a 2. And then I'm going to draw my lines. Some of you keep forgetting to draw your lines. You have to show what's partnering up. Negative 5 partners with 0. Negative 5 partners with negative 4. Negative 2 partners with 1. 0 partners with 6. 3 partners with negative 4. And 7 partners with 2. Our domain, since this is discrete, I'm going to list out my points. So I'm going to do my brackets. My domain is negative 5. Remember my commas. 0, 3, 7. My range is 0, negative 4, 1, 6, 2. Is this relation a function? Why or why not? So I'm going to look at it two different ways. We have three different ways. So I'm going to start by looking at the graph. I'm going to drag my pencil over. If it hits the same pencil, if it hits the pencil twice at the same time, then it is not a function. I'm going to use a paper clip actually, so it's thinner. So I'm dragging it across. It hit it double. So it is not a function. We also can look and we see we have two negative 5s, not a function. I have two negative 5s, not a function. So not a function. The x value, negative 5, has two y values. The 0 and negative 4. Okay? That's what made it not a function, was that negative 5 had two values. All right, let's look at the next one. Which of the following graphs does not represent a function? We're good. We're good. Ooh, hit it twice, but let's go ahead and check my D. Oh, sorry. We're good. So C is not a function. Which of the following relations is a function? So I have two x's, so that's not. X of 3, 4, 5, that's good. X of 3, 3, my x is repeated. And 3, 4, 5, so it looks like 2 and 4 only. All right, so being able to identify functions from different ways. All right, let's look at domain and range. All right, so if I have a continuous line, then it is continuous, and I'm going to be using my greater than, less than symbols, our inequalities. And when we have multiple inequalities, we call them compound inequalities. And so we're going to be doing multiple inequalities, so we're going to be doing some compound inequalities. So let's look at these. So I always start by looking at my endpoints. So I have an endpoint over here. It looks like it is at 0, 0, which is also called the origin. And then this one looks like it's at 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. All right, so I'm going to start with my domain. So I'm going from 0 to 9, my x values. Okay, so it looks like this 0 includes, so it's going to have the equal sign, and this side is open, so it's going to have not an equal sign. Write my second points, 0, my y values, and 6. This is going to be my y. Again, this is closed, so it will have an equal sign. My y is getting bigger. You can see that because it gets bigger to 6. And it's closed, so no equal sign. Let's look at the next one. This one has a line, so I'm not going to have a compound inequality. I'm just going to have an inequality. So let's figure out this coordinate here. 9, 1, 2, 3, 4. 9, negative 4. So we are going to start with our x value. It's going to not have an equal sign because it's open. And let's see what's happening to my x values. Okay, so right now it's at 9. But right here my x value is a negative 1. So it definitely got smaller, so my x is smaller than 9. My y value is going to have negative 4 in it, but let's see what's happening. Right now it's negative 4, but at this point right here, my y is a 1. So it got greater. Okay. Let's look at number 9. Going back to number 8, some of you used the symbols that went with this. If that helps you, that's fine, the greater than, less than symbols. If that helps you, then you're more than welcome to use those. It's not necessarily how I do it, so that's not how I think about it. I told y'all that just the curriculum that we have, the lady who wrote it, she likes doing it that way, but that does not mean that, it doesn't mean you have to do it that way, so if you're not doing it that way, it's perfectly fine. Alright, so let's look back at this. Sorry, this is going to be that it's x greater, this is going to be y, and then the top ones are going to be y is greater, and this is going to be y is less than. Oh, sorry, that should be an x also because it's x-axis. Okay, so some of y'all have learned this and you've memorized it. Just remember that it only works if I have an arrow at the end. And how it works is I'm going, so my x value is going towards this x. That's why it's that symbol. And it's going towards this y, which is that symbol. Okay. I prefer just picking a point later on in the point and seeing what's happening to those x and y values. But if you memorize this, then good. So this one does not have an arrow, so I'm going to have a compound inequality. So I'm going to find out these 2 points. This point is negative 2, positive 3. And this one is going to have a 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Okay, so I'm looking at compound inequality. So I'm going to start with my x values first. My smaller x value was a negative 2, while my bigger one, the other end, is a 4. So there's my x's. Let's see what is happening to those. All right, my x values are getting bigger, and it does not have a close, so it's not going to have a line with it. This one is closed, so it's going to have a line with it, and my x got smaller. Notice over time my symbols are going to go the same direction within both of these. Let's look at the next one. So I have 3, I have 7, it's my y. So let's look what's happening. Going from 3 to 7, y is getting bigger. No equal sign because it's not closed. This one is closed. I should be able to determine what numbers can go in here. 4 can, 5, 6, even 7 because it's equal. All right, let's look at the next one. We have an arrow on it. So again, if you want to use the y's greater than, the x's are easy because it goes the direction, and these are a little bit more challenging. You have to remember which way they go. All right, but let's look. This point right here is the point -3, 5. Yep. All right, so my x value is going to be -3. And if you do it this way, you can see that it's going to be that symbol, but it's going to be equal to also. I prefer to pick a point, so I'm at -3 at this point. My x value is 1, 2, 3, 4, 5. So it definitely got, my x is getting bigger. Let's look at my y and 5. Again, if you use this, it's going this direction, so it's going to be this way with an equal sign. But I can also see that my y right here is a 5, but my y right here is a 1. So it is getting smaller. All right, let's look at doing some function notations here. All right, remember that this just means f of -3 is how we say it. So it tells us we're going to use our f of x equation, not our g because it's an f, and that x is a -3. So I'm going to plug in -3 into my x spot. -3 squared is 9, minus 5 is 4. Or if you remember how to look at the table, I won't help you with the calculator on the test, but if you remember how to look it up on the calculator, then I encourage you to do it that way. Let's look at g. So we have g of -2 equals, so g is going to be -4 times -2 plus 2. -4 times -2 is 8 plus 2 is 10. Let's look at g of -1. So I would go g of -1, and I'm going to go ahead and solve that one. So -4 times -1 plus 2. So -4 times -1 is 4 plus 2 is 6. And then over here I'm going to do my f of 2. Didn't leave myself much room, sorry. It's going to be 2 squared plus 5. 2 squared is 4. 4 plus 5 is 9. And what was I doing to those two? I was subtracting it. So 6 minus 9 is equal to -3. Oh, wait, oh, I made a mistake. Let me figure out what I did real quick. Sorry. Ooh, I made a silly mistake. Hopefully y'all didn't. I wrote my problem down wrong. So I apologize for my mistake. So it was a -5. So subtract 5. 4 minus 5 is -1. So I have 6 minus a -1, which is going to be 7. All right, let's look at number 14. Find the range for f of x, which equals -3x squared plus 4, for the domain of -1, -2, and -3. Again, you could put this in your y equals and go look at your table, Control T, and look those up. But I'm going to go ahead and work them each out. So I'm going to do f of 1. So it's going to be -3 times 1 squared plus 4. So f of 1 is going to be 1 squared is 1. 1 times -3 is -3 plus 4. So f of 1 equals 1. Okay, so I have my range. I have the first point. It's going to be 1. All right, I'm going to do f of -2. Making another mistake. -3 times -2 squared plus 4. Order of operations says to do exponents first. -2 squared is 4. 4 times, write that down. -3 times 4 is -12. Negative 12 plus 4 is negative 8. So my second point is negative 8. And then I have to do my f of negative 3. Now, when it comes to your test, when it comes to STAR test, I cannot help with calculator matters. That's part of learning this class is learning to do it by hand and learning to do it by the calculator. So if you're feeling, some of you don't like doing it by the calculator, and that's fine. But if I can't help you with it, because on STAR test, I'm not allowed to help you at all with it. I can't even if pretty much nothing I can do if it messes up or something. We'll talk about that when we get closer about strategies to deal with how to fix your calculator. I can give you new ones, but I can't fix it for you, if that makes sense. And we'll talk more about that. But if you forget how to do something on your calculator, I'm not allowed to help you with that at all. It's just kind of the state's way of making sure you're learning how to do things for yourself. All right, so there's our 3 points. It's a lot of work to do by hand, but it's doable. I did it without even using a calculator. So, but if you want, you can use a calculator on your phone. All right, let's look at the next one. Which table, mapping, or graph does not show the relationship of negative 4, 2 to negative 1, 6, negative 3, and 5, 2. All right, so negative 4, 2. I'm going to check each of the points. Negative 4, 2, we're good. Negative 4, 2, good. 1, 2, 3, 4. Negative 4, 2. They all match that one. 2, 1, 2, negative 1. 2, negative 1, 2, negative 1, 2, negative 1. Good. And then we have 6, negative 3, 6, negative 3, 6, negative 3, 1, 2, 3, 4, 5, 6, negative 3. Ooh, see if we can find this mistake. 5, 2, 5, 2, 5. Ooh, it has 5, 1. Let's check this one just to make sure. 1, 2, 3, 4, 5, 1, 2. C was not the relation for those coordinates. All right. Let's move on to discrete versus continuous and word problems involving both of those. So let's look. A tank with an initial water level of 15 inches is being filled with water at a rate of 1.5 inches per minute. The water level of the tank can be represented by the function 1.5x plus 15. So what does the variable x represent in the situation? Well, it's attached to my 1.5, so let's go back and read. 15 is being filled with water at a rate of 1.5 inches per minute. So the water level, nope. Is it the number of minutes? Well, it does say per minute. The initial water level, nope. The rate at which the tank is being filled, nope. It is the minutes. Is that discrete or continuous? Can it be filled can I have between times? Is it only 1 second, 2 second, 3 second, 4 second? Or minutes, 1 minute, 2 minute, 3 minute, 4 minute? Or can I have 1.2 minute, 1.3 minute? I can have those betweens, so it's continuous. What would the water level be after 20 minutes? So we know that this 20 minutes is my x value. So I'm going to do 1.5 times 20 plus 15. 3 plus 15. That's not right. Not 3. 30. Ooh, it's been a long day. 30 plus 40 plus 15 is 45. Ooh. 45. And those units with that would be inches, because that's how much it's going to fill. Which of the following is the best estimate of the time it will take for the water level to reach 70 inches? So 70 inches is my y. So I'm going to do 70 equals 1.5x plus 15. Solve for my variable. And x is going to equal 36.6 repeating, which is 37 minutes. If the tank reaches capacity at 102 inches, what's the maximum value of the domain? So we have 102 inches, that's my y value again. So 102 equals 1.5x plus 15. Solve, subtract 15 from both sides. Divide both sides by 1.5. And I get 58. 58. So the capacity 102 inches would take 58 minutes. Which would be my domain. All right, on to page 4. All right, so let's look. We have the graph below shows y, the cost of going to the carnival, and playing X games. What's the initial cost to enter the carnival? Initial means start, my beginning cost. So just to play 0 games, it costs $10. That tells me that it's going to start at $10, that just going in. We're kind of lucky to be in Walker County. We have the fair, and so y'all understand this concept. You're going to pay to go in, then you're going to pay per tickets, or you're going to pay for wristband or whatever. But you pay that one-time initial. And even if I ride no rides, I play 0 games, I do nothing else that costs money, I still have to pay that money to get into the fair. So that's the same concept here. What does the ordered pair 619 mean? So I have 6 is my x, 19 is my y. Well, let's see. X is my games, so 6 games. And my y was my cost, so cost $19. If you play 6 games, the total cost, that looks good. If you play 19, that's backwards. If you spin 6, nope. So A is correct. What is the domain? Now, is this discrete or continuous? It's discrete, so I'm not going to use my compound. And then I'm going to look at my x values. I have a 0, 1, 2, 3, 4, 5, 6, 7 for my x values. Let's look at number 24. Sam wants to have a bouquet of roses delivered to his mother. He goes to Marissa's flower shop where they charge $3 per rose, plus 16 for delivery. What function can be used to find the cost of ordering and delivering roses? So my cost is going to be $3 per rose. That word per is going to tell me multiplication, plus 16 to deliver. Okay, so we got to decide, is this discrete? Is the domain discrete or continuous? So my domain is the R, which stood for roses. Can I have 1.5 rows? No, I can't have betweens. I can have 1 and 2, but I can't have between. That makes it discrete. Sam wants to spend between 25 and 35. All right, so what's the domain? So I'm going to make a chart. Okay. 25 to 35. 25 is pretty close to 16, so I'm going to start probably pretty small on roses. But before we even look at that, it's discrete, so it's not going to be all real numbers. Real numbers has fractions and decimals. Okay, and they start at 3, so I'm going to plug in 3. So 3 times 3 is 9. 9 plus 16 is 25. Oh, that's perfect. Then 4. 4 times 3 is 12, plus 16 is 28. I'm adding $3 for each rose, so it'll be 31. 6 will be 34. And just if you needed to see it, 7's going to be too much. So it's between 3, it's 3, 4, 5, or 6 roses is how many he can buy. Can't buy the 7th. What is the range of the function? Range is my y values, and in this case is my cost. Well, it's discrete, so I'm not going to have my compound inequalities. So what is the range for this situation? For this situation right here. My cost, my y values was 25, 28, 31, 34, which matches D. All right, almost finished. We're getting there. Last page. Which mapping best represents the function y equals x squared minus 3 when the replacement set, the x values, is negative 2, negative 1, and 2? So I'm going to just plug in each of those. So negative 2 squared minus 3. Negative 2 squared is 4. 4 minus 3 is 1. So with my negative 2 is going to be a 1. Here's my y's. So with negative 2 is going to be 1. That has 7. Negative 2 with 1 looks good. Negative 2 with negative 1. Negative 2 with negative 7. I can stop there because I've already figured that one out. I'm going to go ahead and check the second one just to make sure. Negative 1 squared minus 3. Negative 1 squared is 1. 1 minus 3 is negative 2. So partnered with my negative 1 is a negative 2. Very good. Let's look at which relation is represented in the mapping. So I have 1, 2, 1, 2, 1, 2. So C and B are out. I have 2, 4, 2, 4, and 2, 6. So D matched. Which table does not represent y as a function of x? So I'm going to look for duplicates in that x's. So do I have any duplicates? Nope, I'm good. We're looking for the not. 14, 15, 16, 17, 18. That's good. Negative 0.2. Ooh, we have 2. Negative 2/10. I'll go ahead and check D. I have no duplicates, so we're good. All right, now we move on to the review section. I told y'all would see this stuff all year long. It pops up. That way it always is in your brain. It's always being worked. Before we work, I have a subtraction before a parenthesis. So I'm going to go ahead and add a line, change the sign before I even go any further. All right, so 4 times x is 4x. Bring down my subtraction. 4 times 2 is 8. Bring down my addition. Negative 5 times x is negative 5x. Bring down my addition. Negative 5 times 4 is negative 20. Simplifying, so I need to continue. I can't solve because I don't have an equal sign. So I'm going to combine my x's to get negative x, or negative 1x. And negative 8 plus a negative 20 is a negative 28, or plus a negative 28. This one says solve, so we're going to solve. I'm going to move my smaller variable. Leave me with 2, 3x minus 10. Now my x's got a 3 and a 10 with it, so I'm going to add 10 to both sides. Cancels, leave me with 3x. Divide both sides by 3, and we get 4. All right, let's flip to the very back. The length of a rectangle is 7 for a to the 4th, b to the 3rd, and the width of the rectangle is 2a to the 5th, b to the b squared. Find the area. When you remember, area is multiplying, so I'm going to do 7, a to the 4th, b to the 3rd, times 2, a to the 5th, b squared. Okay, so I'm going to start with my whole numbers, my coefficients, and I multiply them like normal. So 2 times 7, 14. Then for my exponents, I have an a, and I have a 4 and a 5, so those get added for 9, and b to the 5th. Let's look at an inequality situation. Alyssa is ordering a flower arrangement. She can choose any combination of roses and carnations for her flower arrangement, and she does not want to spend more than 30. Okay, so we have our 30. She doesn't want to spend more, so she wants to spend less. But she's okay with spending 30. She just doesn't want to spend more. If the roses cost 4 each, what's it say roses are? Roses are X. And carnations, so plus 3.25 for my carnations, which are Y. Which inequality represents all possible combinations? So I'm looking for a 4x. So that eliminates C and D. And I'm looking at 3.25y. Good, good. But this one is the only one that has the right symbol, so B. Last but not least, the cable company charges $75 for installation. That's a one-time, only going to happen once. Plus $20 per month. Per tells me it's multiplication. Another cable company, so I'm going to do theirs over here, does not charge an installation fee, but charges $35 per month. For how many months of cable service would the total cost from either company be the same? Same tells me I'm equal. So I'm going to subtract 20M. Divide both sides by 15. So at 5 months, they would be equal. You'll notice the answers are written at the bottom, so I don't know if that's going to help you or not. They are random. I don't know if it'll help you much because it tells you one's discrete, one's continuous, one's discrete. But hopefully this video helps explain it. Of course, if you have any questions, come see me. I want you to do well on this test. It is your final test of the 6 weeks. Good luck.